and welcome to Disc Ladyada.
Hey everybody, and welcome to another wonderful Sunday. Weather was great here in New York. I hope you enjoyed it. Wherever you are, whether you're working this August or whether you're on vacation, as many people are.
Whether you are, you are the weather.
Wherever you are, whether you are. Do you have any updates you want to tell people about Silicon again?
Yeah, so Here's a reminder. If you're in the San Jose area, we are helping get the word out for Adam Savage and team, friend of Adafruit. We don't get compensated in any way, so go to Silicon SJ. You can join the Savage Makerverse. There's workshops and more. We're doing a bunch of posts across our social media platforms. Do check it out and help continue on the tradition of bringing makers together in workshops, with tools, with people in the community. It is up to you. Go there. We have a code, Adafruit. You get a discount. And again, we get nothing for this. We're just trying to help out. We always like to be transparent and do disclosures. Speaking of, I have nothing to do with Hackaday. I founded the site, but we are also helping them get the word out for the call for proposals for SuperCon 6. We had Magenta Strongheart stop by our show and tell, and I'm happy to see Hackaday continuing on the tradition of the thing I started, which is bringing people together, showing and sharing things. So SuperCon is happening. Do your proposal submission by August 18th. That's the end of this week. Also, stuff that's going on this Friday coming up is CircuitPython Day. So watch everything on our website and
we have streams.
And more. We got a lot going on.
We have a thing we're trying to do that will be really cool if it happens, so tune in on Friday.
Yeah, we'll see. There's a lot of stuff going on.
We're working on stuff.
So with that being said, Ladyada, what is on your desk this week?
Okay, we got a couple things going on my desk this week. First off, I'm trying to get back to some projects that were just delayed due to part shortages, etc. And one of those things is getting back to my camera board. I just started designing this many months ago. So why don't we go to the overhead and I can show it off. So a lot has actually changed since I designed it. When I originally designed it, it used an ESP32 S2 module, but since then the S3 has come out, and the S3 actually has more capabilities. It has a built-in AI module and dual core, so I might actually just swap out this module because it's pin compatible between the S2 and the S3. You get one more GPIO pin. This is the camera module. You got SD card, little speaker. And make it beep when you press the shutter button. There's an on-off switch. Stemma QT and Stemma ports. And then there's probably going to be a plate here to protect the camera module a little bit. And then, of course, the screen. Of course, what you're seeing is a screen of a camera through a screen through a camera. So it doesn't look that great, but believe me, it's pretty bright and clear, and this is very fast. And as I'm doing this, a lot of it's like power supplies, to be honest. Like these camera modules require like 6 power supplies and fast clocking. And one of the things that I wanted to do is, we did have camera support in CircuitPython, but I wanted to also make sure it works in Arduino, especially with this new ESP32 S3 module that Espressif has AI support. And so I wanted to get started with using the ESP32 camera. I basically verified it worked before, but now I really want to really play with it. And one of the things I'm doing is, I have a preview, maybe 240 by 240 RGB, and then when you press the shutter, it would take an image as a JPEG and save it to the SD card, it would be a little snapshot camera. So I was playing around with writing the code for this in Arduino, because that's what it's fine. It's the easiest way to interface with the display and all the sensors and stuff. But for people who've done big projects for the ESP32, once you have Wi-Fi plus a couple modules, you start these modules have 4 megabytes of flash, and you can really start compiling a megabyte worth of binary code to upload to the chip. And one of the things that a few weeks ago, Brent, our developer who works on Whippersnapper, mentioned to me, I've moved the CI and my internal development of Whippersnapper from using Arduino IDE and CLI to using PlatformIO because it's much, much faster to compile. The trade-off of being much faster to compile is there's a lot of things that PlatformIO does to like optimize that, which unfortunately can drive some people a little batty. Like it does a lot of grepping of header files and to try to guess what you're using, and it doesn't necessarily understand macros, which again can be confusing to people. It doesn't use a proper C parser. It kind of has its own thing.
Did you do this on a 2-layer design?
This is a 2-layer design, and it's fine. I mean, it's a little bit warm, but other than that, there's no real reason why you
Where's
wouldn't.
your device? I'll turn it on. Okay, good. I'll take it. Okay. Nice.
Sorry, where everyone wants to hang out. Okay, so I wanted to try out PlatformIO. We also were chatting with PlatformIO and trying to brainstorm with them with some ideas to get them, more funding and support. And so I was like, I haven't used PlatformIO in years, so I thought I would check it out. So I have it installed on my computer, and I thought it took me a couple hours to kind of get the hang of it. But one thing is, like, for big projects. Now again, the compilation method makes it can be a little confusing because. Again, it does a lot of little shortcuts, but if you are an advanced user, there's some really nice things that it does that I thought was pretty cool. So let's go to the computer and I'll just show it off real fast. So, traditionally I write my code in Emacs. Why? I don't know. There's like something wrong with me, or something right with me. But this is PlatformIO, and so you install it with VS Code, which is a fine editor. I just don't use it that much. I'm not a huge fan of IDEs. I find that there's a lot going on. I really just want to like edit code. And again, I know that Emacs commands on top of my head. But so you set up a INI file, and this is a little bit different than Arduino. Like you have these lib dependencies, and for some libraries, the dependencies of the libraries it will auto install. Like it does figure out because all of Arduino libraries now have a dependency line, which is like really great because it means that when you install, for example, an OLED library, we will automatically install the graphics library that you need and the I2C interface, like all the stuff that it depends on. One thing that's interesting is you do versioning. So you tell it what version you want. This is kind of nice because we do versions all the time, updates of Arduino. So it's a bit of a trade-off. On one hand, you don't have to... if you know this collection of libraries all works, you're good to go. The bad news is that don't forget that libraries do get updated, and sometimes they get updated with fixes. So it's a good idea to make sure that you have the latest libraries. You can define per board your platform and set up. One thing I thought was neat that is this is something I've actually asked Arduino to do many years ago, and I get that they're probably never going to do it, but there is no way to add defines, like compile level defines, and it's very, especially when you're dealing with low memory devices, like pound defines can be a really good way of chunking out code, whether you include this or that, to minimize flash and RAM usage. And for example, in BusIO, our I2C interface library, I have a pound define that's in the library that I use all the time, where if I set debug serial to serial, as shown here, it'll print out all the I2C transactions and whether they succeeded. Really handy because you're like, a lot of libraries, it's like you don't necessarily know your I2C failed or it started failing, it doesn't, clock stretching, whatever. So having this debug is handy, and so instead of going and editing that in the library header file, I just define it in the PlatformIO and I rebuild, and it does the right thing, and it's magical, which is cool. And then over here is the command collection, and I have a couple of I'm kind of learning how to add keystroke functions, if I press F5, that builds everything over, and you can see it does a dependency graph, and it has everything installed, and it compiles, and again it compiles very, very quickly. And I did a clean, so of course it's going to be recompiling. But what's nice is that it's for, especially if you're making small changes and recompiling, it's almost instant. And then you can upload and monitor, and it has a built-in terminal, and it knows about ESP tool. For Espressif especially, this is really excellent. I will say, Espressif gives money to PlatformIO, and they're a partnership, and it's, there's one thing is it's you do have to make sure you have the right port, and my port changed. So hold on, I have to rerun it. For expressive, ESP32 especially, it works well. Oh, here's actually something that is actually kind of funny. I use Dropbox, and because Dropbox, for my build directories, files appear and disappear. Like I think this is related. I have issues sometimes where if a compiler is a little bit too fast, it'll create or delete a file in Dropbox. Like takes 100 milliseconds extra to.
Like, hey, let me save that. Hey,
I'm trying to do something here. Yeah. So it's I do. One thing when I do work on big projects. I really do like having Dropbox as like my synchronizer and backup thing, but I do turn it off for the few hours while I'm like compiling so that Dropbox doesn't.
Yeah.
It does updating, like as long as Dropbox is off, it writes, it uploads, so I can do like an iteration cycle in a minute. Now it's not as fast as CircuitPython, of course, but again, there's some code that I have to write that is using stuff that isn't supported in CircuitPython yet, like this AI toolchain, and then you can go up and you can see the output of the terminal, and there's some configurations you can also do with this. So I'm liking it. It's not for beginners. There definitely is a little bit of like you have to learn what it is. Also, I'm using a custom board. I'm not using a board that's in the Arduino IDE definition yet, so like I kind of had to learn how to make that, and it doesn't know about your Arduino sketch folder, so like their libraries have to live in this folder. It's like it's a little bit different. It's really meant for you are working on one big project, not what I usually do, which is I have like 6 different small things going on. But for expressive, I'd recommend it. Don't know if I would recommend it for other platforms because again, this one is officially supported, and the other ones are not, and so they can cause like people who try to use Adafruit board packages in PlatformIO that are not officially supported by the chip maker, it's not a good time because there's all these like weird things that PlatformIO does and Arduino IDE does, and like they may not be compatible. So, but Expressive, they worked really hard to make it a good experience, so I recommend it.
Okay, what's next?
Okay. So let me close this off. Next up, I'll just show some samples and stuff that I'm working on overhead, and then we'll go into the great search.
Yeah, I did want you to show the forums.
Oh, right.
At some point. So, a little bit of a Adafruit note.
Bing bong, update.
We updated our forums, so I'm going to go to that now.
Yes.
So, we'll have, excuse the sawdust, as they say. So, as of right now, we wanted to have a bunch of updates. A lot of things are behind the scenes, but it's faster. There's more features. There's things that make it better for the moderators and more. And you'll just notice that it obviously has an upgraded PHPB backend.
Yeah.
So,
emojis.
Yeah.
This is actually a big deal, by the way, because some people would post an emoji and it would like crash their.
Yes.
Not that crash the forums, but like they would not be able to post it. It'd be like, why can't I post?
Yeah, we understand the modern language involves emojis. So emojis can be used in the subject of a post and also in the post. And we'll have more about this in some tutorial videos as we make sure everything's set. But we've been working on this for a couple of years. It's that big of a deal. So, anyways, that's what we're working on.
Okay. Well, thanks everybody for your patience. It was done yesterday, but there's if you have bug reports, of course, send them in or post them, even better. But we're of course always trying to improve and update our software.
Yeah.
All the time.
Okay, so let's go to the overhead.
Let's go to the overhead real fast. I'll just show off some.
Cool.
I ranted a bit about that stuff, so I want to get going. But the board I'm working on this week is the TCA8418. I designed this like 2 years ago or something, but again I couldn't get the chips. But now actually I did get a reel. This is an interesting GPIO expander, but it's also a keypad multiplexor, which is kind of what it's used for most of the time. It also has Linux kernel support, so you could actually have a little keyboard. So like we had this designed for a little like a display with a keypad, and what's nice is that again this has kernel support, so it like natively works as a keyboard. You don't have to like run a Python script, and you can look at key mapping and stuff. So it has I think 10 columns, 8 rows, 80 keys total. It has like lock and unlock. It's I2C. It's really simple with IRQ. So far, I've got some CircuitPython library I'm working on because I find it easier to write my libraries in CircuitPython first and port them to Arduino because it's just like so much. I have this fast iteration and like I don't have to deal with, hard faults or like if I misunderstand, if I can print out things very easily. So I can get like the basic structure going and the basic understanding of the registers because I'm learning a lot. Like all the little things that you're like, oh wait, that's not what I expected. At least I hit that in CircuitPython instead of Arduino, so it's faster. So I hook it up to my FT232H, and then I'm just I probe it with my scope probe. Let me turn this off so it's not hot. And then I got a couple of fun samples. So the LTR329. I don't exactly remember why I got the sample, I think, but I did look again. It's the cheapest I2C light sensor available on DigiKey, which is why I think I picked it up because I was like, I think what I've been doing is I was working on making like a Circuit Playground Express with the RP2040, and as people know about the RP2040, it only has 4 analog inputs. The SAMD21, which is on the original Circuit Playground Express, and even the NRF52840 on the Circuit Playground Bluefruit both have like 15 analog inputs, and so you can be like, woohoo, 1 analog input for a light sensor, who cares? But if you are dealing with something like RP2040 where the analog ins are rare and hard to get, then something like the LTR329 is tiny, and I2C, and I think it's like 25 cents for the light sensor. So let's just look at it really fast. So I usually get a strip of 10. Yeah, it's nice and tiny. Maybe I can zoom in, and I don't know if I have a light on here. This one. I don't know. Yeah, you can see this. Yeah, it's a little tiny little sensor. And then let's see if I can peel off one, and I'll show it real fast. So, whoop, and then it's gone for good. Okay, so this is it. So you can see it's got 4 little pads. So it's really quite simple. Power, ground, I2C, clock and data. And I'm just going to pop it into one of my cute pink bags. These anti-static bags are kind of what I use to hold my parts and proto PCBs. And then because these silver bags they're great, but they're kind of enormous. And then what I do is I cut the label, so I have the CID, the SKU number, and then I label the bag. So later on, once I approve the sample, or if I'm like, what was this again? I have all the details. Like if I look at this, I can tell when it was ordered, and then I've got the official part number, and then when this arrived, and any revision code. So that makes it just easy for me to organize. I also got a PCF8575. This is a 16-channel version of that really simple 8-bit PCF I2C GPIO expander that we put in the shop 2 or 3 weeks ago. I was like, oh, there's a 16. Somebody was like, oh, there's a 16-bit version, and I was like, I didn't realize that. I picked up 10. They're like, $1 a piece. And again, I'm always looking for alternatives to the MCP 23017, which has just been a tragedy to get. Okay, so that's my samples of the week. So
Do some desk Ladyada.
Let's go do some desk Ladyada.
I mean,
yeah, we're doing that right now.
We are inside of Desk of Ladyada. I mean, the great search inside.
The great search.
Desk of Ladyada.
Okay, do it.
Where in the world is that part I need? The great search with DigiKey.
The Great Search, brought to you by DigiKey and Adafruit. Thanks, DigiKey. Ladyada uses her power of engineering every single week to find the things you need to find on digikey.com. What is this week's Great Search, Ladyada?
Okay, so this week's Great Search is related to this board I just popped up on the screen. This is the board that I designed a few weeks ago. It's the PCA or TCA8584A. This is a STEMMA QT version, the plug-and-play version a very popular 8-channel multiplexor board that we have. So you have I2C chips. As you know, they have addresses. The addresses can't conflict. If they do conflict, then either change the address or you can use a multiplexor. And the multiplexor, it's like you have to like tell it, you know, it's over I2C, and so you send like one special command to the address, you tell it which to connect to, and then it'll reroute the signals, and it, you know, does it transparently. It does work pretty well. I think there's a couple of weirdo chips that don't like multiplexers, but for the most part, they're a great way of just like, hey, I need like that light sensor, the LTR 329. You're like, well, this is a really cheap light sensor, but I need to have 8 of them in a grid. You would use something like this. So I was designing this, but as I was doing this, I thought it would be a good idea to not just have an 8-channel version, but a 4-channel version. And so, because some people are like, well, I don't need something that big. I want a little smaller board. But again, I don't need, or maybe I want like all the pads broken out, but I don't need 8 channels. 4 is plenty. And I agree, 8 is a lot. Like most people don't need 8 channels. So let's go to the computer and see how I did this, because it was a little bit weird to find, and I'll show you why. So this is the TCA8518, and so what I usually do, you know, people know that when I'm looking for, oh, this is, by the way, that light sensor, the LTR 329, is, you know, I'll type it in, and then I'm like, cool, let's find the chip, let's find the chip itself, and there's eval boards, but then I want this multiplexor decoder, and I'm like, yeah, like this is the chip I'm buying instead of stock. I want like the 1x4 one, so I want like an active bus switch, and I want it to be surface mount, and then I'll just select, when it comes up with the search thing, I'll select 1 to 4x1. So, you know, I did that, and when I looked, like there were a couple options, but I kind of had this feeling of like maybe there was something else. Also, they were a little confusing. Like some of these, they weren't like I2, well, some of them were I2C. This one was. But I think like this first one maybe wasn't. I'm trying to remember what it was. Some of them were like, they weren't quite I2C compatible. Yeah, like this was like a different kind of switch. And I was like, well, I don't know if this is... Yeah, this is a bus switch, and that's cool, but I wanted like an I2C multiplexor switch in particular. And, go back. So I was like a little bit confused, because I was like, really, this is all there is? Like, that doesn't make any sense. And then I realized that there's actually, this chip is such a weirdo chip. It actually gets categorized in a couple different locations. And so I was like, oh, you know, I should show people that, yes, you can always search by using the DigiKey Find similar, but there's also a lot of reason to go to the place where the chip fab, the maker of the chip, and use their search, because oftentimes they'll find, they'll have all the parts, and they have a slightly better search for their products. The only thing is, of course, you won't find like competing products, so you have to kind of do this for every company that might make something similar. And then it's like, well, how do you know what companies might make something similar? And the answer is like, you don't really, maybe you just like do the best you can. Like think of, you know, is this something that TI would make? Is this something that Analog Devices would make? Is this something that Maxim or like, you know, Renaissance would make? So in this case, the TCA9548, and you can see here that this is the breakout board we make. It's actually, this one's made by TI. So you'd actually go to TI's site, and then, you know, they have look, DigiKey has like 5 bazillion, literally, different chips and companies, and it's hard to sometimes categorize them exactly, whereas like TI has a lot of incentive to categorize all their products very well, because this is their job. Like their job is to sell their products. They have to make it easy. So for them, they have a whole category called I2C multiplexors and switches. And then what's nice is that you can view all products. I will say, because my monitor isn't that big, that this works best in like 1080p, and this is 720. So you'll see a lot, it's a little easier to navigate these massive tables. Okay, so that said, you can see here that they have a lot of options, and of course they'll have the automotive and the catalog type. They'll give you the approximate price, which is very optimistic, but let's see what we can do. So number of channels, And you can see they have a couple options here for, let's see, do they have number of channels? I think, oh, it's not added to the search, so we have to click on it. And now it's added. So number of channels. So basically how many I squared C to, 1 to X. And we use the standard, the TCA8518A, which has 8 channels, but we want something with 4. So we can go down to here and say we want it to be no less than 4 or no greater than 4. And this will give us 6 options. So then the other thing is you can look at the package group. I do like QFNs the most. SOICs I find to be a little bit too big, but if you're a beginner, of course, they're hand solderable. TSOPs I find annoying. They're hard to rework and they're hard to pick in place. I'm not a huge fan of TSOPs. I like QFNs the most. I find them fairly easy to rework. There's no pins to bend, and they're also very small. But everyone has their own favorites. So you can search by package group. There's another thing you can search by supply voltage. And one thing I noticed as I looked at this is actually there's 6 chips, but there's actually 3 chips, 2 variants of each. So there's the TCA9544 and the PCA9544. And the difference is, one, the number of packages, the number of packages available. So I don't want to click this because it'll pop open. The TCA9544 has only TSOP, whereas the PCA9544 has TSOP, VSOP, QFN. And that's because the voltage is a little bit higher, supply voltage. So, historically we used we used TCA, which goes down to 1.8 volt logic. But one of the things you have to decide is, especially with a chip shortage, is like maybe you're okay with something that has slightly less voltage restriction. So I was like, you know what? I only need it to be 2.3 volts minimum. I don't really need the 1.65. I'd rather have a smaller package. And then there's 3 options. And so then you can look at the difference. One is addresses, which is how many address pins you can set. And I do like having, some address pins. And then there's the question of whether you have reset or interrupt, or reset and interrupt. And you kind of trade off. If you want reset and interrupt, you lose the addresses. I liked having the addresses. So then the question is which one I wanted, the reset or the interrupt pin. The interrupt pin was interesting. You don't go into the details, but you can look at the data sheet. Basically, for each of the 4 channels, you can have an interrupt line and it will OR them for you, or whatever, to get you one interrupt output, which I was sort of like, I was not as interested in because, again, this is going to be with STEMMA QT ports. So I kind of ended up deciding, okay, I want the reset pin with the addresses, so the 9546A. Remember, there's the TCA and the PCA version, depending on, whether you wanted the 2.3 or 1.65 voltage. And then I just went back here and I typed in that half Z. And there's some in decoders here, but what's interesting, it's kind of interesting, there's kind of like a mix and match. Like they appeared here, but they also appeared under interface specialized. And this is where the actual stock was. So there's actually a couple pieces in stock. Another thing is NXP and TI both make the same almost exact part number. I don't know who made it first, so if it's NXP and TI, made a version or the other way around, I don't know. But they seem to use the same part numbers, and they do have in stock let's go to the active ones just to make sure that we're only looking at what's available. They have the TSOP version, the SOIC version, and of course my favorite is the QFN. Looks like TI has a version in QFN, and they're not in stock right now, but NXP also does. There's also a VQFN. I'm not as much in love with a VQFN, but I do like this one. So I'm into this this part. So this is the part I'm going to give samples of. Again, it's nice and small, but easy to rework. I love, if it's, as long as it's 0.5 millimeter pitch, I'm really into QFN. And then as a side note, just because we'll wrap this up, but this category, interface specialized, is super freaky, weird, and cool. Like there's all the weird stuff that doesn't really fit anywhere else, and I just started like clicking around in some of these, and they're all like really kind of cool. There's just like weird like DisplayPort to VGA converters from analog devices, and like multiplexor things, and like what is this TDP something something? This is like a 8 gigahertz linear redriver for DisplayPort. Like it's just the weirdest stuff. So I do recommend checking out this zone. I sorted by what was available, and I just found some really funky, weird chips. A lot of them are on the marketplace. Like some stuff got released to the marketplace. There's some, Bunny had a post about how he thinks there's some cancellation of components. But yeah, do check this out. It's just weird. It's just weird chips, and I kind of love weird chips. Anyways, where was I? Right, the PCA9546. This is my pick for this week's The Great Search.
That's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
Okay, and that is just Ladyada this week. Thank you so much, everybody. We have a bunch going on during the week. Make sure to tune in to all of our social media platforms and all. Thank you so much for joining us and spending some Sunday time with us. Bye, everybody.
Bye, everybody.